Aluminum bromide. How do you write aluminum bromide?
AL.
AL. BR. And we need to crisscross, right? That has a 3. That has a 1. Bring your 1 down. Bring your 3 down. Oh, it's kind of small. All right. AL has a 3. BR has a 1. Bring your 1 down. Bring your 3 down. It's a compound, so we crisscross, right? Plus lithium oxide. What's lithium oxide? It's a compound again, right? Lithium has a 1. Oxide has a 2. Bring your 2 down. Bring your 1 down. Yields lithium bromide. Lithium bromide is a compound. So lithium has a 1. Bromide has a 1. What do you know about those 1s? They're going to cancel out. So I'm not doing anything with them. Plus, you have aluminum oxide. Aluminum has a 3. Oxide has a 2. 2 comes down. 3 comes down. All right, I'm done with those numbers. I'm making them go away because I don't want them at the top. And Miss Wall's too lazy to rewrite it. All right, is it balanced? So I need to balance. So which element you want to start with? Okay, how many L's are here? How many are here? 2. So I'm putting what here? 2. How many BRs did I make? 6. How many BRs? So I'm going to put what? 6. How many LIs did you make? 6. So what am I putting here? 3. How many LIs did we make? 6. How many O's? 3. How many O's? 3. Fabulous. Any issues with number 1? Yeah. Okay, number 2. So in number 2, how do we write manganese 5 oxide? MnCO5. Got it. So it's a compound, right? So Mn has a Roman numeral 5, so that's its oxidation number. O has a 2. 2 comes down, 5 comes down. Questions about how Samaria got that? Plus, what I say, fluorine? All right, fluorine's the first element you've seen. What do we do anytime it's an element?
2.
We ask ourselves if it needs a 2. Is it one of the 7?
Yes.
Yes, that's why it gets a 2. Not all elements get a 2 if they're by themselves. They have to be one of the 7 diatomics. Okay, have you learned the list? You have to know it by tomorrow. How can you learn the elements? Okay, you can remember hydrogen's over here. The other 6 are sort of in this pattern: N, O, F, Cl, Br, and I. I've had people tell me it looks like a gun with a bullet. I think that's a little violent, particularly given the latest things that have happened in the national news. Some people like to use mnemonic devices like Hector, now, owns. It's a stupid sentence before I finish it. 5, clear, brown, iguanas. Okay, there's no such thing as a clear brown iguana. However, the sentence is a mnemonic device based on the symbols and the elements. They all start with the symbols of the 7 elements. Okay, it doesn't matter to me how you learn them. You just have to know them, so when you see them, you're like, oh yeah, that's one of the 7. Okay, so whichever way you want to use, whether it's by location on the table, whether you choose a mnemonic device, you don't have to use the one, and I did not come up with that. Students gave me that years ago. Okay, I used location on the periodic table when I was in school. So when you keep going, the next thing on the question is manganese 5 fluoride. The manganese is MnF. Now, this time, is it by itself? It's not getting a 2. It's a compound, right? So you're going to say 5. Fluoride has a 1. 1 comes down. 5 comes down. Plus oxygen. All right, oxygen is O. It's by itself. Is it one of the 5? 7, sorry. Yes, so we're putting a what on it? A 2. Now, is it balanced? No. You get rid of this stuff at the top. All right, so where do we want to start balancing? Okay, so 5, 2. I can't get 5, I can't get 2, so what am I putting here?
2.
And here?
5.
Okay. How many M&Ns do we make? We made 4. So how am I going to get 4? How many F's did I make? Am I getting 20?
10.
Okay. All right. The last one was just about balancing. All right. And I put this one here and I'll rewrite it because it's kind of small. C4H10 plus O2 goes to CO2 plus water. All right. So I picked this one because some people always struggle with this, and the quiz was no different on Friday. Okay. How many C's?
4.
So how many H's? So what I put here? All right, so counting our O's creates issues. How many O's are here?
8.
Plus, how many O's are here? 8 plus 5 is what? Can I get an odd number here? So what's the trick I told you if you got an odd number? Okay, put a what out in front? Okay, so I'm getting rid of all of this. Rid of those numbers right there, and we're going to try it again by putting a 2 out front. So, how many C's is that?
8.
So I'm going to put a what here?
4.
That 2 only goes to the O.
Oh, 8.
Okay, that's a 1 on the C. So if I want 8, I have to put what number here?
8.
I got to put 8 because 8 times 1 will give me 8 C's. All right, how many H's did I make?
20.
So what am I going to put here?
10.
Okay, now that 2 is important because that 2's on the O. So how many O's did I make?
16.
Plus, how many O's? So 16 plus 10 is 26. That's why I said y'all can have a calculator. So how do I get 26 O's here? 13. Questions? Any questions about how to do that? All right. Can we look at some homework, see how we did on the ones that we did? Because some of those that I looked at when I was walking around, I made some comments on for some of y'all because, whoo, some of them are just bad. I don't know if it was, I was just trying to make sure I had something written down from Ms. Wall if she checked or what. Some of them are just bad. And maybe it was just, I just needed something written down in case Ms. Wall walked around and checked my homework. And if that's the case, okay, I understand. You know, I was in school once too. I wanted my points. But if that's what y'all are turning in tomorrow on this quiz, I'm going to be suicidal by the time I finish grading. All right, so we said 1, 2, what was the other one? 3. There's 3, 5, and 12 will be on the next page. Okay, so there's 1, 3, 5. Let me ask this class about justice real quick. I'm not going to be here every day.
I have to read one chapter every single day in order to catch up. You could listen to a book.
For real?
I would probably. That's the one that you do.
Yeah, I probably zone out, especially if it's like a monotone voice. You could. I did that with. Oh, Fitzgerald. You can do it. You got it. Fitzgerald. You sleep good?
It might knock me out. I took a nap yesterday. I know.
All right, ready? All right, number 12 would be this one here. That would be 12. All right, which ones do I need to do? Okay, none of them are Samaria. The rest of y'all better not say nothing.
Nothing for me.
Okay, so if we had the quiz today, I'd grade all hundreds.
Yeah.
Ain't no
I
way.
probably wouldn't get 100.
Ain't no way based on
maybe
some of the,
85.
ain't no way based on some of the homework I looked at.
I got it. Give me a calculator.
Yeah.
No, ew.
Because if we can't do this, we're toast on today.
All right, let's just go over number.
Okay. I mean, I don't buy it, but I'm perfectly content moving on. Okay? I mean, I've told you before, I don't get paid on the number of A's, B's, C's, D's, and F's. My goal is to have more at the upper end than the lower end of the grades. Okay? I prefer to look good than to look bad. That's my goal. All right, so number 3 was what? What did they say on the worksheet?
Antimony,
Okay, antimony would be SB.
5.
Okay, so Roman numeral 5 means what? The oxidation number is a 5. Okay, what did they pair antimony 5 with?
Carbonate,
Carbonate. All right, so carbonate is CO3. And what's the oxidation number on carbonate? Okay, a 2. So I put your parentheses there, bring your 2 down, bring your 5 down. Plus. All right, what is it reacting with?
manganese,
Manganese,
7.
7 permanganate.
Yeah.
Okay, MnO4, and it has a -1. So parentheses, 1 comes down, 7 comes down. Now, today, we're going to have this, and that's it. Okay, when we get down here to double displacement, that's this thing. That's all I'm going to give you. You're going to have to give me everything else after the arrow. Okay, so tell me what it said next. I mean, I can do it myself, but I'd rather put it in the same order for you.
Antimony,
Okay, antimony's first. All right, so antimony, 5 permanganate, right? So Roman numeral 5. Let me give myself a little more space here. Antimony, 5 permanganate, MnO4, has a 1. So 1 comes down, 5 comes down. Plus manganese has a 7. Carbonate has a 2. So 2 comes down, 7 comes down. Now, generally, these are ones students do the best with because you don't have to mess with what? Why do you think students generally are going to do the best with these? They don't have an element. They don't have to worry about whether anything is diatomic. Everything crisscrosses. Okay? So, the hardest part for most people in this is going to be balancing. So, what do we want to balance first? Okay, MnO4. We can do MnO4. So, how many MnO4s? How many MnO4s? So, we're going to put a what here? And a what here? Okay, how many SBs do we make?
7.
Can I make 7?
No.
Okay, so let me get rid of that. Okay, pick something different.
CO3.
Okay, so you got the same problem, 5 and 7. So we're going to do the same thing. We're going to put 5 and we're going to put 7. Okay, so how many SBs do we make?
14.
Can I make 14 SBs?
Yeah.
Okay, how many MnO4s did I make? How many?
70?
Yep. All right, so can I make 70 MnO4s?
Yeah.
I got 7, so I'm going to put a 10 there. So how many MNs did I make?
10.
How many are here?
10.
Yep. Questions? No? Everybody's okay?
Number 12.
Sure. Number 12 says, give me the hydrocarbon. To see something. See what?
C3H.
C3H. 8. All right. And it says plus oxygen, right? Oxygen is O. It's by itself. It's an element. So is it one of the 7 diatomics? Yes. So we're going to put a 2 on it. Yields. All right. Think biology class. You guys all know this compound. What's carbon dioxide? CO2. It's an old system naming. It's one of those compounds you're always going to see in old system naming because it's a compound that scientists are more likely to write in old system naming than a stock system. Okay? Did Miss Thornhill or Miss Bowers ever call it carbon 4 oxide? No. Okay? All biology teachers, all college professors call this compound in its old system name. Okay? So it's carbon. There's no prefix on it, so it's just one C. Dioxide means how many O's? 2. Okay? If you don't know that one, memorize it. Plus, what's water? H2O. Again, if you don't know that one, I would memorize it because you're going to need to know it. All right? From there, the problem people have with it are always the oxygens. So how many C's are here? So what are we going to put here?
3.
Okay. How many H's?
8.
And how am I going to get 8?
4.
Okay. Now count. How many O's is that?
6.
How many O's is this?
4.
What's 6 plus 4?
10.
How do I get 10 here?
5.
There you go. Everybody got it?
Yeah.
Okay. Anybody else? Question? All right. Find your notes on types. Okay. We're going to talk about types, and then we're going to move on to predicting products. All right, we got started on this on Friday, right? Because I didn't get to it in third period, but I was thinking I did y'all in here. All right, so on Friday, we did the first 2 in here, if I'm not mistaken. So when we look at the 5 types of reactions, single displacement and double displacement are the 2 we're going to learn to predict today. Single displacement is always an element plus compound. Now, one of the ways that you can recognize single displacement, I told you on Friday, is it has how many plus signs? It has how many plus signs? I heard one little weak voice out there.
2.
Has 2 plus signs, okay? That's going to be different from synthesis and decomposition that we're getting ready to talk about because they're each only going to have 1 plus sign. Now, in anything that's labeled displacement or replacement like we wrote down on Friday, what has to happen with 2 elements? They have to do what? They have to switch and change places, which is what we're going to work on today. Now, single displacement and double displacement work the same way. 2 things change places, except for double displacement, you have no elements. Everything is a what? Everything's a compound. So you have 2 compounds. They become 2 compounds. So if you look at this one, how many capital letters do you have in each of these compounds? 2, 2, 2, 2. That's how you know they're compounds, right? So if I go back here, how do you know that's an element?
1.
It only has 1 capital letter, right? So that's an element. That's a compound. That's a compound. That's an element. Okay? Everybody with me on that from last week? Okay. So the third new type is synthesis. If you want to abbreviate, it's just a capital S, which is why I told you last week, if you mistakenly write S for single displacement, will I take it? No, I won't. Okay, S means synthesis. So, synthesis means you form 1 compound. Now, this 1 compound can be identified because there will not be a plus sign on the right side of the arrow. Okay? You will know that there's only one compound because there is no plus sign on the right side of the arrow. That's why I said it's easy to find single and double displacement, because there's how many plus signs? There's two. There's a plus on the left, there's a plus on the right. But with synthesis, there's only going to be a plus where? On the left. There isn't a plus on the right side. All right, so this, you're going to have any combination of elements and compounds, okay? You could have an element plus an element. You could have an element plus a compound. You could have two compounds, okay? This could be any kind of combination, but you're always going to get one compound, okay? It's going to have no plus sign on this side. So I've given you, let me give you one more here. Okay, so in the samples that I've written down, these two are what types of things? What's K? What's Cl? So this one is two elements make one compound. What's Na2O? It's a compound because it's got two capitals. What's CO2? So this one has two compounds, okay? So two elements make a compound. Two compounds make a compound. What's this one? What's this thing?
That's a compound.
What's this? So this one's a compound plus an element. So that's what I mean by you can have any combination. There's no set standard of what you're going to have. But what do you notice about all the products? What's missing on all three of these things? There's no plus sign. Okay? On all three, there's no plus sign on the product side. Okay? So when you look at all three of those reactions, there's no plus sign on the product side. It didn't matter that in the first one I had two elements being added. In the second one, I had two compounds being added. Or in the last one, I had a compound plus an element being added. That was all irrelevant. When they were all added together, I got one compound and there was no plus sign. Does that make sense? Yes? No?
Yep.
Okay, I feel like I'm just talking to myself today. Okay. Is everybody caught up with me? All right, decomposition is the exact opposite. Okay? We symbolize it with a capital D. Okay? Now, you know from biology class, the decomposition means something breaks apart, breaks down. Okay? This is the opposite, the inverse, the reciprocal of synthesis. So, one compound is going to break down. It's going to break apart. And this is supposed to say ELE, not ELS. Hey, Ms. Floyd, what you need? Okay.
What you thinking about registration now?
They got ACT to quiz, so for your class, second period. We had only 7, I think, that needed to be registered. The others are. So, are you involved in
I'm not.
quiz? Okay. Can I just ask them real quickly? How many of you have not been registered? We was thinking most of them have. Is it gonna be a problem for time?
I record my class, so those that are here, I'll teach. Everyone who's not here in the room can watch it via YouTube later that evening.
Very good. Anybody, okay, scheduled for the ACT tomorrow that needs to be registered? Okay, so we're good. We only have 7.
Okay.
Okay, good. Thank you.
Welcome.
sorry for the interruption.
Not a problem. All right. So you have one compound that's going to break apart, okay? And that one compound can break down into any combination of elements and compounds, okay? And remember, after we learn how to tell the types over the course of the next few days, we're going to learn how to do this. Now, again, here are some samples. So the first one, I gave you a compound that breaks down into two compounds, and then I again gave you one that breaks into two elements. So if I give you the same one I gave you a second ago, this one will break down into a compound plus an element. So this one broke into, what are these two things? What's this? What's this? Everybody okay with that? So you start as a compound, you break down into two compounds. This one is a what? And it breaks down into what? Breaks into elements. This was a what? And it broke down into what? Compound and an element. So you can get any combination. Now, what's different about this versus the last one? Where do you not have a plus sign? On the left side, okay? So this time, there's no plus sign on the reactant side, okay? So there's no plus sign on the reactant side.
Will it always be on the left side?
Only if it's decomposition, okay? Does everybody have what they need? Or do I need to wait? Let's see, one or two still writing. Okay, now the last one is my pet peeve. All right, combustion, we give a big C. Now, this is the only one that we've done out of the last four that I can give you actual compounds for. Okay, notice I wrote hydrocarbon. And under it, I told you a hydrocarbon is just carbon and hydrogen. We're going to add oxygen. And we're going to get what two things? Carbon dioxide and water. Have I given you any actual elements or any actual compounds in the last four types? No. This is the one that drives me bonkers. Okay? Drives me bonkers when people get it wrong. Okay? Because this one always has the same elements and the same compounds in it. It never changes. In the other ones, I had to say things like elements plus compounds. 2 elements, 2 compounds. You have to figure out whether it fits a particular format. This one has the exact same elements all the time. Okay? And yet people get it wrong. Now, this, the only thing that changes is the subscripts. Okay? It's a C with an H. So the only thing that changes is what number is here and what number is here. That's the only thing that changes. Okay? Could have 1s, it could have 2s, it could have 3s, it could have 4s, it could have 5s. The numbers change of what goes in those little circles. That's it. But it's always a C and an H. How do we write oxygen? O2. How do we write carbon dioxide? CO2. How do we write water? It never changes. Can I have other elements thrown in?
No.
Never. Okay? No other elements. It can only be these elements by themselves because that's the definition of combustion. So if it has some sodium thrown in, can it be combustion? No. Never. Okay? You can't have any other elements thrown in. If you see an equation that just has water, can it be combustion? What's the format for combustion? What's it say right here? A hydrocarbon, meaning it had to have what, 2 elements? C and H. And the only thing that varied on the C and the H were the what? The subscripts. And then it had to be added to what? And you had to get what 2 compounds? So if you have an equation that just has water in it, can it be a hydrocarbon plus an oxygen getting CO2 plus water to be a combustion reaction? No. Okay? It doesn't work that way. If you see a reaction that just has carbon dioxide in it, can it be a combustion reaction? No. You got to have all 4 parts and only those 4 parts to be combustion. Okay? So, this would be a combustion reaction. Why is it combustion? Oh, really? It's got carbon and hydrogen. What's it added to? What 2 things do you get? No, it's not okay. Okay, is this one combustion?
Yes.
You sure?
Yes.
Yes.
No.
Yes.
Yes, it is. It just got different numbers.
It's just got different numbers. Okay? The only thing that's different are these little numbers. That's the only thing that should be different. Okay? Everything else should be the same. Okay? That's it. So if I wrote C10H22 plus O2 goes to CO2 plus water, would you tell me that's combustion or no?
Yes.
You should. Just because I made these numbers a little larger doesn't mean it's not combustion. Okay, it's still combustion. Right?
Right.
I did.
Yeah. Yeah, sure.
When is this quiz?
Tomorrow.
Oh, no. I ain't going to school tomorrow.
And
I'm
so,
gonna make it.
Oh, I'm gonna
make
make
it.
Oh,
Oh,
guess
yeah.
what? We got the little quiz
But I
paper.
still have to
If you
make
came
it.
to the
Oh. Jesus.
I don't know why on earth you would want to use one of those on this quiz.
hey,
There are harder quizzes you might want to use it on than this.
Oh, I'm not using them in your class.
I bet this is looking at my car. It's all so very well.
Okay. Quiz. So we're gonna
So-
there was so many
back to your
colors.
side.
All right, hold this for a minute before you all wig out and are like, I need it. Yes, you can. Stop with the I can't.
I haven't even got a paper yet.
All right, so hold that for a second. All right, so if we look at this, okay? So if we look at number 1, for example, all right, how many plus signs do we have up here?
One.
Okay, so it can't be which ones? How many plus signs do we have here? How many plus signs? Okay. How many plus signs do we have here? How many plus signs here?
One.
So synthesis has 1. Decomposition has how many?
One.
Okay. Combustion has how many? Okay. So single, double, and combustion have 2. Everybody with me on that? Synthesis and decomposition have 1. All right. So if I cruise back over here to the questions, how many plus signs do you see?
One.
So it's either synthesis or decomposition. Are we forming something or are we breaking apart?
Forming.
All right. Let's jump down to number 3.
Hold up, wait, hold up. This paper not the same as the-
I'm aware of that. These are practice questions. And we're going to do the paper in a minute. I said, leave the paper alone.
Oh.
I said, set it off to the side for a second. Y'all don't ever listen. Number 3. How many plus signs do we have?
One.
Two.
I said number 3.
Oh, 2.
We got 2. So what kind of reactions have 3 plus signs?
Single disposition.
Single displacement.
Single displacement.
displacement.
Double displacement and combustion. What do we know about combustion?
It's got the same four elements.
Which are?
Hydrogen,
That's
carbon,
like
oxygen,
carbon
You gotta make some carbon dioxide and water. Do we make some carbon dioxide and water?
No.
So we know it's not combustion. Now, single displacement was an element plus a what? Did we have an element plus a compound up here? So it's not single. So it's what kind? See how I'm eliminating? You should be able to do that too. Okay? Yes.
Makes sense.
I didn't even answer anything.
Don't go over it.
So in number 2, for example, what would you tell me it is?
It's
Composition.
How many plus signs do I have?
one.
So it's either synthesis or decomposition. Is it forming or is it breaking apart? That's how we knew it was decomposition. All right, if I go to number 4, how many plus signs do we have? So it's either single, double, or combustion. Which one do we know it's not? So it's either single or double. Do I have elements or do I have all compounds? So it's got to be single. All right, how many pluses do I have in number 5? So it's either single, double, or combustion. Do I have anything that strikes me? You got the idea?
Yeah.
Now, if you would be ever so kind, see if you can answer 1 through 14 on this paper. Yes. I'll be glad to. Number 6 on that board has it has a parenthesis. So what is that thing? It's a compound. As soon as you see those parentheses, it says you am a compound.
What was it? How's your day been, Miss Wall?
I can't complain. Well, I'm looking at this email. Stephanie, you're going to room 31 tomorrow. If I got anybody else in here. Jaden, room 31. Darlene, room 31. That's it. Room 32. Andy. Maria. Room 33. Tiffany. It's all over there beside Miss Thornhill, that hall.
Yeah.
Dr. Curry and Miss Boston. By side.
So Miss Ricky thinks she can stay in.
I don't think so. She honestly think she might move. We were talking about this morning. Tiffany. Ashanta. And I think that's it. Room 31 is Wednesday. All right, Wednesday. Who do I have Wednesday? For room 31. Talia. Karen. First thing in the morning. Room 32. Jonathan, Eduardo. Autumn, Sophie.
Where's room 32?
Same place. All of the rooms are the other side of Zionsville. Okay, it's that hall. It's those 4 rooms. Okay. That's room 32. Okay.
You sound like a little old lady.
And then room 33 for Wednesday is
And I'm gonna punch you.
Sit down.
Okay, I'm trying to do my work.
I don't know if we have anybody for that one. All right, this will be Thursday. Marissa, you're in room 31. Tomas. 31. Yep. Abraham. Y'all are on 31. 32 on Thursday. Xavier and Justice, please. Okay? And children assignment. So if you can remember it, you don't have to spend time searching the signs in the hallway. If you can't, check the signs in the hallway. All right, number 1, what'd you come up with? Synthesis. Number 2, double displacement. Number 3, synthesis. 4, single. 5, decomposition. 6, double. 7, single. 8, single. 9, synthesis. 10, good. 11, single. 12, synthesis. 13. Do you have 1 or 2 plus signs? 1. So whoever said double, that's not double because you only have 1 plus sign. Okay, it is synthesis. And number 14, decomposition. Now this ends the quiz for tomorrow. Being able to tell these types is the end. Word equations and types are on the quiz tomorrow. Okay, what we're getting ready to do is not on the quiz tomorrow. All right, let's talk predictive. All right, now. We're going to learn to predict using single displacement. Now, before we can do that, let's talk about what I need for that. All right, I think that's the one I want right there. All right, so if we look at these reactions, okay, these are the 5 types mixed up. This is what you will be looking at by Thursday, and you have to predict what the other side looks like on the test, okay? Now, in the first one, what type of reaction would that be based on what we just did? Okay, this first one will be decomposition. All right, what does the second one look like to you based on what we just did? Single. All right, I hear single and I heard synthesis. Okay, how do you decide whether this is single displacement or synthesis? Which one do you think it could be? Okay, why synthesis and not single displacement? Okay, there's no compound. Okay, there's no compound here. So that's how you decide it's not single displacement. Okay, what about the next one? That one's single displacement. How do you know it's single displacement and not synthesis here? Okay, it's an element plus a compound. Okay, what about the next one? That one should slap you. Double displacement. And what about the last one? Combustion. Okay, is everybody okay with that? All right, now we're going to start simple. Oops. And we're going to start with predicting, and we're going to start with single displacement. So for those of you who are into titles and your notes, we're going to do predicting. Now, we're going to start with single displacement. Single and double displacement are the easiest two to do. And we're just going to start with single. Sometimes I'm convinced that double is easier, but I like for you to get used to the rules, so I tend to start with single. Now, predicting in a reaction. Suppose we want to do iron 3 plus antimony 5 oxide. Yields. That is a standard single displacement reaction. Iron 3 is your element, antimony 5 oxide is the compound, and we want to predict what we're going to get on the other side, correct? So, what are we going to need to do this? Okay. Number one, you have to look up the oxidation numbers. Okay. Now, I'm also assuming that we've already written this into symbol form. I'm assuming we've done that know how. Okay. We're going to look up the oxidation numbers. Number two, we're going to switch the two elements with the same sign. By sign, I mean either both positive or negative. All right, you're not going to have both of them being. You're not going to have two that. Well, you will have two positives and two negatives when we get to double displacement. You will not in single, and I'll explain that when we get there. All right. Now, once you've done the switching, use that color. All right. On the product side, compounds crisscross, elements check if diatomic. And 4, I write in here, even though I should not have to, balance. We never write an equation that we don't balance, okay? If you write it, it has to be balanced. Did everybody hear me say that? If you write an equation, you balance the equation. Even if the directions don't say balance. If you wrote the equation, you have to balance the equation. All right, have I given everybody time or do I need to wait? Okay.
What's that word?
Check it, diatomic, balance, crisscross,
Yeah, the clouds on. Good,
diatomic. All right, you caught up? Everybody? All right. So, let's say that we do, because I don't want to do that one. I gave you a hard one to start with. Let's say that we do, I don't know, let's do aluminum plus SB2O5 yields. I'll just vary it slightly, because I'm not going to start with one where you got to write the symbols and all that first. All right, so let's start with one that's already in symbol form to begin with. So the first thing we want to do is do what? If this was all mixed up on a test, you'd determine the type, but we're already there. We already know this is what type. Single, because you haven't learned how to do anything else, right? But this is a what? This is a what? So if this is an element plus a compound, you would know it was what type? You would know it was single displacement, correct? Okay, just checking to make sure we're all on the same page. Why'd that go back to that? All right, so we know. Okay, that's better. All right, so step one is to do what? Check the oxidation numbers. What's aluminum? All right, you need the positive and negatives because step two is to switch the two that have the same sign. So is it +3 or -3? It's +3. All right, so that's a +3. What's antimony? The +5. What's oxygen? -2. Now, step two, we're switching the two that have the same sign, not the same number. You will either have two that are both positive or you will have two that are both negative. You will not have, until we get to double displacement, two that are the same. When we get to double displacement, you will have two positives and two negatives, and I'll show you what to do there. Okay? Now, I did not say that we were putting the two positives together. We're switching them. Okay? So this positive is going over there, and this positive is going over there. Sort of like you have a boyfriend and your other girlfriend wants him, and you're just switching. Okay? He's trading you out for switching the girlfriends. Okay? It's kind of tacky, I know, but he's just switching. Okay? He liked the other one better, and he traded you for a new model. Okay? So, antimony and aluminum are switching places. Okay? It's not that you decided you didn't like boys, and two girls are going together. The dude is switching to girlfriends. Okay? Are you with me on that? Okay, so antimony is now going to be by itself, and aluminum is now going to be what? It's going to be with the other. Is everybody with how I made the switch before I do anything with the numbers? Okay, because that's the hard part. Once you got that done, the numbers aren't as hard to do. Some people put the two positives together. We're not putting the two positives together. Now, when you do your numbers, you do the same thing you just did over the weekend for the other side. Compounds do what? If they're elements, you check to see if they're what? Diatomic. So when you come back over here, is antimony one of the 7 diatomics? It gets nothing. This is a what? So you take your oxidation numbers and you put them in. So aluminum had a 3, oxygen had a 2. So what do I do with those numbers? So 2 comes down, 3 comes down. Now, I can't work with all that crap up there. So I'm going to rewrite it. So Al plus SB2O5 yields SB plus Al2O5. Now, from there, I need to do what? I need to balance. Pick an element you want to balance with. Yeah, was that a 2-element one or what? Oh.
Why is there a 5 at one?
Because it came from, oh, that's a tacky looking 3. Thank you. Thank you for fixing that for me. Let me change the color. That's a 3. Thank you, because that would have completely messed things up. Thank you. All right, so what do we want to balance first? The ALs, we can. All right, so how many ALs here? There's 1. There's 2. Oh, you want me to put a 2? Okay, there's a 2. Got it done. Okay, next. Okay, how many SBs? So I'm putting what here? Okay. Next. It wouldn't have been right to start it, but what have I picked? That's what I picked. I would have not done those because they're standalone elements, and I can always add whatever they need last. I'd have picked O's because it's tied up in the AL and the SBs, and then I'd have done AL and SB last because I can fix them at the end. Okay? So how many O's? How many O's? So I'm going to put a what here? Mm-hmm. And then because I made how many SBs? I could easily just come here and write what? 2. Exactly. I made how many ALs? 10. I can easily just come here and write 10. That's why I do those last, because they're easy to just go ahead and fix at the end. Questions about how I did that? Okay. So if we do another one, let's say that we have, and this is what I'm going to write in words. Fluorine plus nickel 4 oxide yields. Okay, so this time we have to write it in symbols, and then we'll have to predict. Okay, so how do we write fluorine? F2. All right, I hear F, and then Tomas said put a 2 on it. Why did Tomas say put a 2 on it?
Special.
It's special. It is one of the 7, so it gets a 2. All right, plus, this is a compound. What do I got to do for compounds? Crisscross. So nickel is what? That's a symbol. Ni. Some people still mistakenly write N. Make sure you fix that. So nickel is a 4. Oxide is? What do you notice about those real quick? They can reduce. So I'm going to need to reduce them when I crisscross them, right? So 2 and a 4 need to become a what? 1 and a 2. Because if you forget to reduce, you lose points. All right, so that was a positive. That was a negative. Now I need fluorine's oxidation number. What am I going to use? It's not 2. It is -1. Fluorine, chlorine, bromine, and iodine. When you look them up, they all say -1, +1, +3, +5, and +7. The only number we will use for them pretty much this semester is -1. So when you're looking them up, they're always going to be -1, okay? And half the time you guys are always going to ask me, it's -1. And you're going to need to know that by test day. Okay? They're the -1. So this time, who's switching? The negatives are switching. So what am I going to get on the other side if the negative switch? So this time, O's coming over there, and F's going over there. So what am I getting on the other side if those two are switching?
NiF2 plus O2.
Okay, drop all those numbers. So it's Ni with what? Ni with the F, and then plus what? With the O. Don't take any numbers with you, okay? No numbers cross the arrow except, anybody know which number can go across?
Diatomic.
The fluorine.
The what? Except polyatomic ions, which is the one I'm going to talk about next. Okay? If you're a polyatomic ion, you can go across the arrow. Have I done anything with a polyatomic ion yet? So nothing can go across the arrow. It all stays on the left. Where do your numbers come from on this side? Where do they come from? We did what? We crisscrossed, or we checked to see if they're what? If you take numbers with you, they're in the way when you go to crisscross or check if they're diatomic. So they don't get to go across the arrow. Okay? Oops. One more. All right, so now, if you had, did anybody want to write theirs down as O plus NIF? Would that be okay? Yes, it's perfectly fine. Okay? Just depends on which way you saw it. If you did, it's fine. Okay? So, where do I get my numbers from? What's NI? Okay? What's F? So 4 here, 1 there. What do we know about O? Is it 1 to 7? It gets a 2. Okay? So I'm going to erase that because I need space. So I've got F2 plus NI O2 yields NI F4 plus O2. All right, so from here, is it balanced? No. What's not balanced? What I need to do? Exactly. Exactly. And everything else is good. Feel okay about that? Okay. I'm holding. All right, we got it? All right, let's do one with a polyatomic ion. Let's say that we use, well, something we don't use all the time. Let's say we have zinc phosphate. And we add sodium. And we have this. Okay, and so we have that. If you want. And the director, she's killing your ability to keep your points at the end. Yep, because you're going to wind up doing lunch attention because you're your last one. Take the vest, my dear. All right. So, what do we do? What's the N? Yep. So, what's its oxidation number? Plus 2. Phosphate. And sodium.
It's a plus 1.
Plus 1. Okay. So, from there, what do I do? Okay. So, who's going to be with who? Na is going to be with who? Okay. This is the only place a number gets to go across. Who's in the parentheses? That 4. That 4 is part of phosphate. When you look it up on your blue card, you see how that 4 is a subscript on phosphate? What? Do you want something? Now, 4 is part of phosphate, right? It's part of the polyatomic ion. Everything that's in here, you cannot touch. So, that 4 gets to go across the arrow. Okay? Now, this 2 here came from the oxidation number, right? It doesn't get to go across. So, leave it alone. But that 4 gets to go. Plus, who's over here by himself? Zinc. Okay? Now, from there, we need what on the Na and the PO4? What do we do here? Oxidation number. So plus 1 and minus 3. That's why I leave my oxidation numbers written right here, because I don't have to look them up again. They're already right there in front of me. So Na has a 1, phosphate has a 3. I'm going to have a 3 here and a 1 there. And zinc is by itself. What do we know about zinc if it's by itself? Is it a 2 if it's by itself? Is it one of those 7? It does not get anything because it's not one of those 7. It's not a Hector now owns 5 clear brown iguanas. So it gets nothing. Okay? So getting rid of those. Getting rid of that. Getting rid of that. Get rid of some extra lines I drew in there. All right, so based on that, what do I need to do? Okay, how? What you want to balance first? Okay, how many PO4s are here? So what am I going to put here? Okay, 2 phosphates. All right, how many NAs did I make? So what I put here? Okay, that only leaves zinc. How many zincs? So what am I going to put here? Think you could try a couple?
I got a question.
Yeah.
Why wouldn't zinc get
Why wouldn't what?
Why wouldn't zinc get
Because we don't drop oxidation numbers like zinc. It's got a +2. We don't drop oxidation numbers straight down. We don't do that. Okay? So when you write any element by itself, like zinc, you always ask yourself, is it one of the 7? Okay? Same thing happens. Let's say you write, or I give you something like iron 3. Okay? When you go to write this symbol, iron has an Fe. A lot of people want to write that as iron with a little subscript 3 on it. We don't do that either. Iron is one of the metals on the periodic table. Is iron 3 one of the 7 diatomics? It's just Fe. We don't put anything on it either. Is that for when you do what? Exactly. If it's not one of those 7 diatomics, if it's by itself, it gets nothing. Okay? It either gets a 2 because it's one of the 7, or it gets nothing. There's nothing in between. Okay? All right, let me get some we're going to practice. All right, that was the types. This is the one I want. All right, these are divided into single and double displacements. Don't work ahead. We haven't done double. All right, we're doing 1, 2, and 3 at the top. We're doing 1, 2, and 3. And then we're going to see how you did. All right, who has a question? Grab my pencil here. That 2 right there. Okay. So, we're going to 2 there. Oh, you're balancing. Oh, okay. Just check. All right. Seven, get each up. You want balance, or you want to switch to it? What do you want with that? By itself? Now, you put the two negatives together. You want to switch the two negatives. So instead of putting them together, you want to switch the places. So NA is currently with 2. So you want NA to then do 2. You're switching the two negatives. Okay. Yes. Yes. And then what's it? Yes. Okay. Here. And this is by itself, which is a 1 side.
If it's a compound and you look at the calculation, you use the numbers just in the equation, not the numbers just in the statement. It's just by itself, you don't have no. Unless it was a.
How are you doing? I'm just so
I
happy.
spilled one through the 3.
That's very important. If you'll go behind my gray chair, there's a tall thin fountain.
I mean, I got.
There's some wipes in there instead of wasting all those very towels. And it'll help with the sticky. Okay?
Okay.
Behind my gray chair.
What you saying?
I ain't say nothing.
Ignore him. Just go over there behind that tall gray chair. You
I did not say anything.
should see some wipes.
I promise you
When
that.
I slap in.
I promise you that was not me.
Okay. Don't blame me now.
You ain't got to.
Okay, that's fine.
Don't punch me, please.
Just 1, 2, and 3.
A horn is not the prettiest. Those are 7 diatoms, okay? So when those elements are by themselves, you put 2 of them. That is this, one of those 7. Put 2 of them, okay? And this is a compound. There's cross your oxidation numbers, okay? Yep, they're both 1s, they cancel out, now you're ready to balance, okay? What do you do with both of them? Okay, so I didn't check the balance, I just looked at the switching and the oxidation numbers. Give me the balance in the first one. Okay, so make sure I have the balance in. All right, now make orange go. Make orange go. So how you gonna make it have 2? Yeah. How many NAs did you make? Make up 2 NAs. How many Fs did you make? How many Fs are there? Blah. How are you? So let's try that. Oxidation reserve. All right, here you're fine. Here you put the 2 positives together instead of switching the 2 positives. This one's +1 and -1, so there's 2 there. Don't bring the 2 across. And this one you. I'll bring that 2 to see that. Bring your oxidation to understand your +1 times 2. Your problem is you're trying to bring these things over. Don't bring them over. No numbers come across except like that little 3 inside. That little 3 inside, that's it. Nothing else goes across that arrow. You should be okay. What you got? All right. See how you put F and Cl together? You put the 2 negatives together. You want to switch the 2 negatives. Okay? This 2 is chromium, 1 of the 7 diatomics. Hector now owns 5 clear brown iguanas. Is it in there? That's what I'm asking you. Hector now owns 5 clear brown iguanas. Or where's your periodic table? It doesn't matter. Okay? When you look at H, N, O, F, C, L, B, R, and I is chromium, 1 of those 7. It doesn't get a 2 on it. Okay? So you check that off. All right, you put the 2 negatives together also. You want to switch the 2 negatives. This has a -1 oxidation number. This has a -1 oxidation number. They're switching. You have a -1 and a -1 oxidation number. They can't be together. Mm-hmm. All right, and then plus F2. Okay, so that's better. All right, these oxidation numbers are wrong. This one is +3, times -3, so it's going to be +6. Yes. All right, let's look at some of what you came up with. I stopped and made suggestions on a lot of people. Some of you over on that side had not gotten very far when I was over there, so I didn't get to see as much of what you had done. Okay? Come on board. Work from here. Oops. All right, so in the first one, +1, -1, -1. Some people put F and Cl together. When you go to do that and you have 2 negative oxidation numbers together, can you put 2 negative oxidation numbers together? No. Remember, whenever you make a compound, what kind of oxidation numbers have to be together? A positive and a negative, okay? So when you put this together, chlorine and fluorine are switching. So you get Na with Cl and then plus F. Now, second mistake a lot of people are making is they're bringing the 2 from this side to this side. Can you bring any of the subscripts over? No. Unless it's part of something in parentheses like that 3, it doesn't get to go across the arrow. Whoops. Back over there. Okay? So, +1, -1, they cancel. Fluorine is by itself. Is it 1 of the 7 diatomics? Yes. So, put a 2 on it. To finish balancing it, you need a 2 on fluorine. Make 2 sodiums, 2 sodiums. Number 2, this 3 is in parentheses. It gets to go across. +2, -3, +3. So, aluminum is going to be with PO3. When you put the positive switch to that positive, chromium will be by itself. Notice the only number that came across the arrow was the one in the parentheses. So, +3, -3. What's going to happen to those 2? They're going to cancel. Don't even bring them down. Once you bring them down, you're probably not going to cancel them. Chromium is by itself. Is it 1 of the 7? No. Okay? So, get rid of all of this. Get rid of this. And this, and balancing, 2, only 1 there, 2 aluminums, 3 chromiums, 3 chromiums. The last one, again, you have nitrate, which is a polyatomic ion. We're going to switch +2, -1, +1. We're switching the two positives again. So Na is with the NO3. Lead is by itself. Is it one of the 7?
No.
+1, -1. What are we going to do with those ones? They're going to cancel out. Go away. Okay? So from there, 1, 2, we're going to put a 2 there. 2 NAs, 1 lead, 1 lead. All right, let me tell you what your homework is. On the front side, I want you to do 4, 5, and 6. On the back side, I want you to do 1, 2, and 3. Okay? For those of you who are taking the ACT tomorrow, I'm going to try not to go super far. Okay? Those of you who will have to register, you won't miss the entire class unless you are the slowest register on the planet.
No, you have 4.
Okay.
Yeah.
All right. Well, if you got Miss Floyd and you're there for an hour, it's on YouTube. Watch it. If you missed the quiz, it's your responsibility to make it up. Okay? It is what it is. Okay? Class stops for no man.